stimulate the release of gastric. I did not tell you the molecular mechanisms by which acetylcholine stimulates gastric. And I did not tell you the molecular mechanisms by which gastric acid inhibits the secretion of acid. So those you don't have to know. But I do want you to know that the nervous system and the stomach itself, the nervous system and the stomach itself has sensors that help control gastric acid production. CCK and secretin are mostly, so we could do this in pretty much detail. CCK and secretin, where are they secreted from? Well, let's do it one step at a time. What cell types cause the secretion of CCK and secretin? Those are the cells that respond to CCK and secretin. What are the cells that release CCK and secretin? They're hormones, so these have to be endocrine cells. These are endocrine cells in the duodenum. What did they detect to cause the secretion of CCK and secretin? They detected the kind. They detected acid, fatty acids, and amino acids coming from the stomach into the duodenum. CCK and secretin were secreted. Secretin primarily caused the duct cells to secrete bicarbonate to neutralize the acid. And secretin neutralized the acid. And secretin primarily is responsible for secreting the zymogens and enzymes necessary to digest the stuff that's coming into the duodenum, the chyme coming in. So you want to be able to tell these stories from what cells detect it and what cells respond to it in each of these cases. So we could do that, we could do that in part for a lot of these. What cells detect a low pH chemoreceptors? What do? They tell the brain to increase ventilation by increasing the contraction of the diaphragm and increasing contraction of the sternocleidomastoid and the external intercostals in order to increase lung ventilation. So you could tell your story, could go back and tell your story from the perspective of what cells detect it, what do, and then what cells respond to it. We could do that for all of these. What cells detect low blood pressure? Baroreceptors, and then we're off and running with all these stories. This system works for all systems that have an antagonistic, things that work against each other. It doesn't work for everything. But it works for a lot of what we've been talking about in this course. So my recommendation is to make sense of these, but don't memorize these. Spend your time figuring out what are these graphs telling you about the physiology, and then unpack those physiological stories to the molecular mechanisms as best you can, to the greatest detail that you can. My recommendation is to write out the story as you're trying to tell it, because writing is what you'll do on the exam. By activating those pathways, you're putting it in a part of the brain that you'll be doing on the exam. My recommendation is to outline it. You don't have to write essays, just write, bullet points. And then check your bullet points against your notes or against the slide, and say, okay, yeah, I mentioned water permeability, but I didn't mention aquaporin, and I didn't mention GS, and I didn't mention vasopressin, and I didn't mention vasopressin receptors, I wouldn't get full credit for an answer that asked me to explain that pathway in detail. That sort of thing.
In terms of the final, will you be expecting us to flush out like the cross-bridge cycle of GT-CRs?
I will try to be explicit. If I expect you to tell me a G protein story, the question will say, tell me intracellular signaling pathways and cross-bridge cycle. If it doesn't, and you can be telegraphic at this point, if you say GS activated, alpha, GDP, GTP comes off, GDP comes off alpha, GTP comes on. Alpha separates from beta gamma. Alpha activates adenylyl cyclase. You can, and you don't need, for activate, you can use an up arrow, right? You can do this in a very telegraphic manner. I don't need to see literature from you. I just need to see that you know the fine details. Yeah.
I have a question about the format. So is the majority of the exam going to be kind of like a long answer, like 30-point question, so it's going to be smaller questions?
There's a mixture, but there will be some of those question at the top of the page and then a lot of white space to fill in the answer. Yes, there will be some of those. Yeah.
So for the blood pH, when the chemoreceptors, let's say they detect a low blood pH, so they want to increase ventilation.
Yeah.
And so increasing the contraction of the diaphragm via the phrenic nerve. So is the phrenic nerve releasing norepinephrine?
No, the phrenic, so that's a neuromuscular junction. So the phrenic nerve is actually releasing acetylcholine, but it's not activating muscarinic, it's not activating GQ, it's activating the nicotinic acetylcholine. This is just like, the diaphragm is a skeletal muscle. So this is going back to AMP1 or to cell phys, and I couldn't ask you about this because it's AMP1 or it's cell phys, but the phrenic nerve is releasing acetylcholine, which is triggering contraction of skeletal muscle. That's an AMP1 story. You remember this. This is the neuromuscular junction. Acetylcholine, T-tubule, da-da-da-da-da. Well, I skipped a whole bunch of steps there. Acetylcholine, acetylcholine receptors, sodium channels, action potentials along the muscle, T-tubule. Now we're into the story that you actually got for the heart of this class. T-tubule, calcium release, intracellular calcium, troponin, tropomyosin. I'm available a lot, so just send me an email and I'll try to reply via email if it's a simple text question that I can answer via text. If it's not something that I can answer quickly via text, I might ask to have a Zoom meeting so we can just talk about it. But I'll admit that sometimes I enjoy, if you send me a hard question, I sometimes enjoy writing out a clear paragraphical answer. So don't hesitate to send me an email question, because I'll either send you the answer by text, or I'll just say, oh, this one's really complicated, I need to draw it out on the board, let's have a Zoom. I'm also pretty good at referring you to the slide number of a slide from, go to PowerPoint 21, slide 16. Here's what I'm looking at when I explain the answer. Okay, so keep your eyes on this part of the Moodle page, because things might switch around. I don't want to send a bunch of emails and then a follow-up email and a follow-up email. This is where I will be updating the schedule for the practical. this is the way it was before I came down here to class. It might change in 5 minutes when I go back up to my office and start to read some more emails. If things, I gotta say, if things blow up and I'm told it is not safe for students to be in a room together, I don't know what I'll do. So keep your eyes on this page, because if the things blow up and I can't have people, at least even in pairs, I might not have enough slots to do this, but I'm hopeful that we can do this soon, get it done. I think you will find the experience of a practical quiz or practical exam is something that is intrinsic to this course. And so I'm sure hopeful, and I want to keep trying to have a lab practical quiz even though we have some COVID on campus now. Right now I feel like this is still safe, but it's being updated hourly. If you don't feel safe, I do not want to put you in a situation where you feel unsafe. Just contact me and I will do the best I can.